Greetings! This recording covers the lesson on sampling. At the end of this lesson, you must have discussed the reasons for sampling, determined the corresponding sample size based on certain factors, and differentiated among sampling techniques. Let us first recall some terms relevant to understanding sampling. A sample refers to a part, portion, or a subset of a population, while a population refers to a collection of certain measurements, objects, or individuals, which is clearly described under certain considerations. A characteristic of or a value obtained from a sample is referred to as a sample statistic or simply statistic, while a characteristic of or a value obtained from a population is referred to as population parameter or simply parameter. To obtain a sample from a certain population is called a sampling. It is used to make inference about a population or to make generalization in relation to a theory. In many cases, the best or only way to describe a population is through sampling. Several reasons support sampling. First, certain tests are destructive. There are instances in which, in order to determine the characteristic of a certain object requires its breaking point. As a result, it may no longer be of use. This case is usually true in a production, such as in a certain manufacturing firm that requires the measure of tensile strength of a certain product. Nothing may be sold if all the products will be subjected to test for their minimum tensile strength, since it requires their breakage. Second, checking all the items or members of the population is impossible. Difficulty in gathering all members of a population may be encountered, such as determining certain parameters about animals may be troublesome. It is impossible to gather a population of birds, fish, snakes, and the like. One may not easily contain them in a certain location. Third, studying the entire population is costly. Conducting certain tests may require a large sum of money. Issues on COVID-19 are good examples of this. In the case of the test to check whether one is positive, the necessary cost cannot warrant in order for everyone to be subjected. Even the cost to determine the impact of this pandemic among Filipino may consume a large amount if all will be involved. Fourth, results obtained from the sample are adequate. There are instances in which the difference between a parameter and a statistic is too insignificant since variations among values is too small, like in the selling price of products, which is controlled by the DTI. Hence, the difference of most products may only be few cents, especially if the products are from the same manufacturer. Fifth, contacting the entire population is time-consuming. Involving all members of a population with geographical consideration may consume not only a huge amount of money, but also a considerable amount of time. Imagine how many months or even years to complete the census of the Philippine population. Taking into consideration the mentioned reasons of sampling, the following are some discussions on certain scenarios. First, let us suppose that one intends to know the taste of a food item being prepared. If all of the produced food items will be tested, then nothing may be left to sell. Another case is on determining certain characteristics of mosquitoes. It is impossible to gather them all. Even if the population is defined to limit only those within a barangay, mosquitoes cannot be easily contained. Lastly, What about determining the daily allowance of students in the Philippines? How much effort will one need to do the census? It will require much budget as well as take a lot of time in order to reach out to all students in the Philippines. The involvement of the entire population certainly provides the most accurate measurements or test results. However, as discussed previously, there are cases in which sampling is the only way to describe a certain population. The next issue is on how many members of the population is needed. This prompts to the methods of computing for the sample size. With this, there are various schools of thoughts on determining the sample size. To ensure that tests generate statistically significant results, the determination of appropriate sample size is very important. The aim is to be able to involve not too large or too small, but a good representative of a population. If the sample size is too small, then a failure to detect what is intended to is likely to occur, while if the sample is too large, then an unnecessary investment resources is at stake. Taking into consideration the practices of the various researchers, these are some ways on how sample size is determined. We will cover three approaches only. These are an arbitrary counting number, a certain percentage of a population, and using Slovin's formula. Aside from these, there are other methods being suggested by considering statistical power. Depending on the situation, certain formulas to calculate the sample size are recommended. On an arbitrary counting number, there are cases in which the size of a population is not easily determined. One example is determining the acceptability of a certain food item. The population of such consumer cannot be easily determined. Hence, some researchers consider involving a fixed number such as 10, 30, and 50, in which others refer to it as quota. Although some suggest 30, in which they relate it to the central limit theorem, Chakrapani explains that there is no such a magical number. Notwithstanding, there are those who apply this even if the size of the population is known. When this is used with two or more samples, it usually results to non-proportionate sampling. Example: a study on the preferred telecommunication network among male and female first-year college students, both from public and private schools, is to be conducted. If it intends to involve a total of 80 students equally represented by each gender, what is the size for each sample? So the sample size is equal to 80 divided by 2, which is equal to 40. It will involve 40 male students and 40 female students. With the same case, if it intends to involve 140 students equally represented by each type of school, what is the size for each sample? The sample size is equal to 140 divided by 2, which results to 70. It shall involve 70 students from public schools and 70 students from private schools. With the same case, if it intends to involve 200 students with equal number of male and female students for each type of school, what is the size for each sample? Sample size is equal to 200 divided by 2 divided by 2, which is equal to 50. It shall involve 50 female students from public schools, 50 male students from public schools, 50 female students from private schools, and 50 male students from private schools. On a certain percentage of a population, in some cases, researchers would opt to consider a certain percentage of a population which is also arbitrary. The use of this approach requires that the population size must be known. When this is used with two or more samples, it results to proportionate sampling. Example: in a firm that manufactures a certain electronic device, there are 3 production lines. One lot of each line consists 100 pieces of such device being produced every 2 hours. The operation lasts for 8 hours a day. Each day, samples are taken for quality test. What is the sample size for each lot if 10% of the products are tested? Sample size is equal to 100 times 0.1, which is equal to 10. 10 pieces per lot for each line. With the same case, what is the sample size every 2 hours if 15% of the products are tested? Sample size is equal to 100 times 3 times 0.15, which is equal to 45. The sample size is 45, composed of 15 pieces from each production line. With the same case, what is the sample size for each production line if 12% of the products are tested? In 8 hours, there are 4 of 2 hours. Hence, each production line produces 400 pieces of such electronic device each day. The sample size is equal to 400 times 0.12, which is equal to 48. The sample size is 48, composed of 12 pieces from every 2-hour production. With the same case, what is the sample size each day if 8% of the products are tested? In 8 hours, there are 4 of 2 hours. Hence, each production line produces 400 pieces. Since there are 3 production lines, there are 1,200 pieces of such electronic device produced by the firm each day. The sample size is equal to 1,200 times 0.08, which is equal to 96. The sample size is 96, composed of 8 pieces from every 2-hour production for each production line. Let us proceed to another example. The administration of a certain school intends to study the learning styles of their students. The enrollment data are described in the table. There are 1,326 students. When they are classified according to year level, 256 are 4th year, 330 are 3rd year, 342 are 2nd year, and 398 are 1st year. When they are classified according to gender, there are 598 male students, and there are 728 female students. What is the size for each sample if it intends to involve 20% of the students and compare among year levels? From 4th year, 256 times 0.2 is equal to 51.2. The sample size is 52. We need to round up since it is safe to consider a fraction as one person already. From 3rd year, 330 times 0.2 is equal to 66. The sample size is 66. From 2nd year, 342 times 0.2 is equal to 68.4. The sample size is 69. And from 1st year, 398 times 0.2 is equal to 79.6. The sample size is 80. On using Slovin's formula, this approach also requires that the population size is known. The following describes the Slovin's formula. Sample size is equal to the population size divided by 1 plus the population size times square of the allowable margin of error. Let us apply Slovin's formula in one of the previously mentioned examples. That is, the administration of a certain school intends to study the learning styles of their students. The enrollment data are provided in a table. Using the Slovin's formula at 0.05 margin of error, what is the sample size if the students are taken as a whole? Applying the Slovin's formula, it resulted to 307.30. So the sample size is 308. We need to round up since it is safe to consider a fraction as one person already. Using the Slovin's formula at 0.05 margin of error, what is the size for each sample if the study intends to compare between male and female students? Applying the Slovin's formula for male students, it resulted to 239.68. So the sample size for male students is 240. Applying the same formula for female students, it resulted to 258.16. So the sample size for female students is 259. Now, let's proceed on how to determine who or what to be included in the sample. Generally, sampling techniques can be divided into two: probability or random sampling and non-probability or non-random sampling. Probability sampling ensures that every member of the population has a chance to be selected. In random sampling, bias is eliminated, while non-probability sampling lacks this characteristic. Non-random sampling is usually used with case study research design and qualitative research in general. The following are considered to be probability sampling techniques: simple random, systematic random or simply systematic, stratified random or simply stratified, and cluster sampling. While non-probability sampling techniques include the following: quota, accidental, snowball, and judgment or purposive sampling. Please take note that random in statistics is not the same as the word random in colloquial. On simple random, with this technique, each member has equal chance to be selected. Hence, it requires a list of all the members of a population. The method employed is similar to lottery draws. The process may include the following. First, prepare pieces of paper with the same size and quality. Second, write the name of each member on each piece. Third, put them in a box. And fourth, one at a time, without looking on the writings, draw a piece until the desired number is taken. Alternatively, the following steps may be done. First, assign a unique number to each member. Second, using certain application, generate random numbers depending on the desired sample size. And third, the member corresponding to the generated numbers will be part of the sample. On systematic sampling, this technique requires a certain order or arrangement of the population. The method includes every nth member of the population after a certain random start is selected. This technique is sometimes considered by others as non-random technique because of the defined method. This may be used whether or not the population size is known. For a known population size, the steps to employ include: first, determine the desired sample size. Second, divide the population size by the desired sample size. Third, round down the result. Call this as n. Fourth, generate a random number from 1 to n. The selected number is the starting point. And get every nth member in the order or list starting from the generated random number. There is a need to round down the result in order not to get a sample out of the list, but this excludes more members at the later part. This is part of the reason why there are some who do not consider this as a probability sampling technique. On stratified sampling, this technique is used if two or more independent samples are to be considered. Strata or subgroups are identified such as by gender, male or female, and year level, first year, second year, third year, and fourth year. The method considers whether a proportionate or non-proportionate sample is selected. On cluster sampling, this is similar to stratified sampling, although this technique is usually applied in which the members of the defined population are scattered over large geographical areas. It is referred to by Etikan and Bala as area sampling. It may also be employed to any large population by dividing them into smaller units with similar characteristics and randomly choose certain cluster as a sample. Moreover, Etikan and Bala as well as Taherdost named multi-stage sampling to further the clustering to reach a narrow selection of the sample. For the succeeding, the colloquial use of word random may be observed in some techniques. On quota sampling, this technique takes into consideration predetermined characteristics such as religion or race of the population for a member to be included in sample. Any member of the population with the characteristics defined is included in the sample until the desired size is met. On accidental sampling, this technique is similar to quota sampling, but with the absence of the predefined characteristics. Any available member is included until the desired size is reached, or involved only those who are available at a certain time or place. Hence, others refer this as convenience sampling. On snowball sampling, this technique is usually applied when there is a difficulty in reaching members of the population. The method starts with identifying a few who are known to be part of the population, and then they refer to others whom they know. On judgment or purposive sampling, this technique takes into consideration the judgment of the researchers on which members they may obtain the best data needed for the study. Inclusion in the sample is deliberately chosen by the researcher. Usually, this is employed in case studies. In addition, Etikan and Bala introduced expert sampling as the sample consists of what is believed to be experts of what is being studied, which still takes into account the judgment of the researcher. For better understanding on the difference among sampling techniques, the following example is provided. Let us assume that the Commission on Higher Education Regional Office 6 intends to determine the internet connectivity among college students in Western Visayas. Because there are many higher education institutions in the region and there is an urgent need of the results, the mandate was to apply sampling. Depending on the study, one may identify the most appropriate sampling technique based on some considerations. But it is even possible that several sampling techniques may be applied in one study, commencing with an initial sampling technique. In this study, among the most appropriate initial sampling techniques to choose from are as follows: cluster sampling, stratified sampling, quota sampling, and accidental sampling. Why cluster sampling may be initially employed in the aforesaid study? Western Visayas is comprised of 6 provinces and 16 cities covering more than 2 million hectares of land. With this, the population may be clustered by provinces and cities. Then, Simple random may be used in determining which provinces and cities will be included. Further sampling techniques such as another cluster or simple random, quota, and/or accidental sampling may be employed to cover a more manageable number of schools and students to be involved. Why would one opt for stratified sampling as the initial technique? Instead of treating provinces and cities as clusters, they may be considered as strata. Schools may be grouped according to their location, whether in the city or province. Then, either the same number of schools or the same proportion of schools from the province and city will be chosen. Random sampling and other techniques may be employed further to identify the specific schools and students to be involved. Alternatively, the strata may be based on whether the school is public or private. Other ways of grouping them, in which certain factors are assumed to affect the connectivity, may be considered. The intention to determine the difference of certain characteristics of the population is necessary in determining the strata. If there is no intention of comparing certain characteristics, then stratified sampling may not be considered. Quota sampling may also be employed as the initial technique. With the pandemic, not all school officials and students are easily available. Hence, any college students who are currently enrolled in any higher education institution in Region 6 may be approached until the desired number of students is met. After identifying the quota, other sampling techniques such as accidental sampling may be considered for a more convenient way of identifying the respondents. However, there is a possibility that only those students with better connectivity may be involved, or most of the respondents may be coming from certain area or type of school only. The results may not be a good representative of the population, hence, generalization may not be possible. Alternatively, accidental sampling may be employed initially. Again, because of the pandemic, not everyone may be reached out easily. Moreover, since time element is a necessary factor, then there is a need to identify the schedule of data gathering. Any officially enrolled college students in Region 6 who are available during the scheduled data gathering will be involved. These may or may not consider a certain number of students. Just like quota sampling, the results may not be a good representative of the population. It is even worse if only a few students are available on a certain schedule of data gathering. Based on the given example, the difference among the sampling techniques is on how they are carried out and with certain motive or purpose. To obtain a more representative of the population, among random sampling techniques are the best options. However, if there are some constraints, then among non-random sampling techniques may be the only best choices but may not result to a good representation of the population. This marks the end of our lesson on sampling.